In this activity, we are going to learn about convex and concave polygons. The objective of this activity is to understand the concept behind the types of polygons, that is convex and concave. To understand this, let's have a figure like this, where I have taken 5 sides and you can see all the interior angles. I'm marking all the interior angles here. If you measure all these interior angles, each of these interior angles will be less than 180 degree. And there's one more property. All the diagonals, whether you draw diagonal like this or you draw a diagonal like this, the diagonals are going to lie entirely in the interior of the polygon, and therefore this type of polygon is known as a convex polygon. Likewise, if you have another figure which is drawn like this, here you have 6 different sides, 1, 2, 3, 4, 5 and 6. If you see the interior angles which I am marking, they are all less than 180 degree, but one of the interior angles, this one, is more than 180 degree. So in a polygon, if even one angle is more than 180 degree, then that type of polygon is known as a concave polygon. And some of the diagonals of concave polygon are going to lie outside. That means outside the polygon. It may be the entire diagonal or a part of the diagonal which will lie outside. Suppose I join these two vertices A and B. You can see this diagonal lies outside the polygon, and therefore it is known as a concave polygon. To perform this activity, we need some material, and the first and the most important one are colored sheet of paper, or you can pick up the white paper sheets and color them. A pair of scissors for the cutting work, scale, sketch pens and geometry box. These are routine material which are required to perform this activity. So let's see how we can perform this activity of convex and concave polygons.
In this activity, we first take a plain sheet of paper. You can take a white sheet of paper, or in this particular experiment, I have taken a colored sheet of paper. So as you can see some cutouts here, how these cutouts have been generated from this sheet is by folding this sheet along random edges like this. You can fold it randomly and lot of creases will be formed. So as you can see, I have already folded it and you can see lot of creases are formed. So what you need to do is to cut this sheet along all these creases so that you have random shapes or random polygons which are cut out. For simplicity's sake, I have already cut this sheet and all these polygons are obtained by cutting the sheet. Now one by one we will pick up the polygons. For example, this polygon, if you consider this polygon and you paste it on a plain sheet of paper, then you can see that if you join this vertex to this vertex, this diagonal will lie completely outside this polygon. So in the table, the observation table, we need to see, this is the first figure, and portion of diagonal, whether it is exterior or interior. Yes, in this case this diagonal is exterior, so you will write in the observation table corresponding to that polygon number, you will write yes, the portion lies in the exterior. And you can measure all the interior angles of the polygon, and one of these interior angles, this one in this case, will be greater than 180 degree. Now whenever you have some portion of the diagonal lying outside the polygon and one of the exterior angles or two of the exterior angles greater than 180 degree, then that particular polygon is a concave polygon. We'll see another one. If you see this one, it looks more like a parallelogram, but you never know, it may be a simple quadrilateral also. Likewise, this is a pentagon. So if you paste this and draw any diagonal, that particular diagonal is going to lie completely inside this polygon, and all the interior angles of the polygon will be less than 180 degree. So in this case, the diagonal does not lie in the exterior and all the angles are less than 180 degree, and therefore the type of polygon is a convex polygon. This is how you get different shapes and identify whether all these polygons are convex or concave, and that completes our activity on polygons.